Okay, hello GH 101. We're in our beginning programming with R stuff, and we're moving through just classic beginning programming programs, keeping some notes about what we're learning along the way, and that's it. That's what we're doing. All right, so let's move on to the next one, which we've got. Okay, testing if n is prime. This is excitement. All right, so I'm going to start a new file for this, and I'm going to call this we'll call it prime.r, capital R. That's the tradition. All right, so I want to say some number. So I'll use n as typically a variable name for integers. So let's say we have the number 15. That's a special number. Okay, all numbers are special. And I want to know, is n prime? So first of all, tell me, is n prime, yes or no? It's not. Okay, it's not prime because it's 3 times 5. Right, 3 times 5, so it's not prime. Okay, so the basic algorithm for testing if n is prime would be something like this, and we'll see whether this works or not. So I want to say if I divides n, then not prime. Okay, so there's an error because I can't just say n I divides n. Okay, so first this is supposed to be the numbers from 2 up to n minus 1, and I'm not sure if that's actually going to do what I want. So I'm going to try it out down here first. So there's my value of n. Now I want to look at what does 2 colon n minus 1 actually do. So 1, 2, 3 up to 14. That's what I wanted it to do. All right, so that's okay. Now I need to check this. So what I want to say is whether n divides I. In some programming languages, you would say this like this. It doesn't like that. That's okay. Okay. So what this percent, and in R here it's double percent. What this percent is the remainder. So we could make note here of our punctuation. There's punctuation to do arithmetic. So arithmetic, we have plus, I'll just say plus, minus, times, divide. That works just the way it does on a calculator. I have percent here, double percent, and double percent is remainder. So if I do 15 over 5, that's 3. If I do 15 over 4, what is it going to be? So it's 3.75. It evenly divides. So if I divide 4 into 3, so it is true that 15 equals 3 times 4 plus what? 3. So if I say 15 double percent 4, the remainder is 3. So this percent divide percent gives me the number of times 4 goes in evenly, and then the remainder is double percent. Let's try another one. So 20 divided by, let's say, 7. So how many times does 7 go into 20? 2 times, with a remainder of what? 6. If I just want the decimal value, that's the regular slash. Okay. So percent slash percent is rounded down. Okay, that's often useful in programming because integers, we deal a lot with integers. All right, so what I want to say here is does n, so if I do the remainder and I get a 0, I do the remainder and get a 0, that means I found something, n is not prime, and I'll say divisor, I found a divisor, and then I'll say I here. All right. So let me, why don't you pause and predict what exactly is going to be printed. All right, now I'll run it. So I have 15 is not prime. I have divisors of 1, 3, and 5. Let's print this again. That's not what I want. Go back over here. Okay, so let's print that thing again. Right, so that's not exactly, I wanted to go from 2 up to, and you probably noticed that because you're actually paying attention. So what I really want is 2 up to n minus 1. I don't want 2 up to n and then minus 1. Okay, so there's a difference. This one here, you have all the numbers from 2 up to n. So all the numbers from 2 up to n is 2 up to 15. And then in R, if you have a vector, so if you have a bunch of numbers, this bunch of numbers is called a vector. It's just a list of numbers, but a particular stored in a particular way. It's called a vector here. So we have 2 up to 15, and if you do minus 1, R does something kind of useful, and it subtracts 1 from each one. So 15 minus 1, 14 minus 1, each of them got subtracted by 1. That's not what I wanted to do. I really wanted to do this, 2 up to 14. All right, so there was a logical error in my program. All right. Let's run it again. Now predict what are we going to see. So we have 3 as a divisor and 5 as a divisor. Super. And we also have a new use of parenthesis. Parenthesis for order of operations in math. What if we put in, let's say we have, instead of 15, let's say we have 36. What do you think is going to print? So we get all the divisors of 36. Okay. So this is our prime program. There's definitely more efficient ways to do this, but there's something. What if we put a prime number? 17 is prime. All right. What do you think is going to print? Pause and tell me what's going to print. Now I'll run it. Nothing. 17 is prime. We never printed this because we never found a divisor, but then we didn't print anything. So what I'd like to do is I would like to print something at the end. So I have something here that says found divisor, and I'll initialize that to be false, capital false. And then here, if I find one, I'm going to say found divisor is true. Okay, and then after my loop, if I did not find a divisor, then I'll print yippee, n is prime. Okay, so this is a logical data type called Boolean it's called Boolean in programming and math. True or false. It's case sensitive here. Capital letters false and capital letters true. So found divisor is a true or false thing. I started off saying I haven't found any divisors yet. If I ever find a divisor, I set it to be true instead. And then I'm just going to check here at the end, and this exclamation point is supposed to mean not in programming. And if I don't find any divisors, it must be because n is prime, and this is the paste where I can put multiple things in the paste there. So what do you think is going to print now? Yippee, 17 is prime. What if we do 36 again? We get the printing there. And we have another punctuation item. We have comparison operators. And we now have logical operators. And this is not. Okay. Now if I want to run this with some other integer, let's say we want to test 2019, is that prime? It's not. What about 2021? Maybe it is, maybe it's not. Let's see. It's not. So if we want to run this on different numbers, then we have to go and change the code. All right, so I'm going to give you your first function. I'm going to make this into a function. So I'm going to say isPrime function n curly brace I'm going to indent all this stuff because that's what we do in programming. Now I'm going to try and make sure this does the same thing as it did before. Okay, let's see. All right, so this is how to create a new function in R. So we have some stuff that we want to be able to use multiple times with different values of n. So I have all that stuff that I want to be able to use, in order to be able to run it easily with different values of n. So I have that in between curly braces. I have the keyword function, and then whatever the thing is that potentially is going to change each time, I have a letter there. So that's the letter that I was using. And then I have this as the saving. I'm going to save that function into a name called isPrime, and then later on I can call isPrime if I want to call it with, let's say, 202. Okay, 202 is definitely not prime. All right, so I'm going to put some notes over in our basic programming. So these are the concepts that show up no matter what programming language you're using, pretty much the same. So functional procedure. So getting into the sort of nitty-gritty details of functions. So there's always going to be some way to define or create a function. And then there's going to be some way to call or run the function. So those are typically the two things the language has to tell us. So creating the function is this. The rule for R is you have the word function, you have parentheses, you have variable names in there, and you have curly braces. And then you have the name of the function with the less than dash and the name. That's defining the function. So if I do this here, that's not going to run, that line. What do you think will print? Nothing prints. This here creates the function, but doesn't actually run the code. That happens when you call the function. This is called calling the function. So when I have something like this with the parenthesis, R goes and looks, is there a function named isPrime? If there is, I'm going to run it. And the action of running a function has a few steps, typically. So you define or create a function. So call or run the function. Running the function has a few steps. You copy parameters. You run the code. You return a value. Okay, so over here, before this code is going to run, the first thing that happens is this value 202 is copied into a new variable called n. So the first thing that happens is it's just like there was a line like this. R does that for us, or whatever was in between the parentheses when they call the function. Okay, so that happens first. That's the first step. Then whatever the code is that's here, it gets run. And then the last step is a return value, which we don't have, but I'll go ahead and put one here. Return not found divisor. And then I'll say like this. All right, so I'm going to source the file and run everything. I see my printing happened, 202, and then you might have noticed the value of x now is false. All right, so my third step now happened. First step, 202 gets copied into a new variable called n. The code runs. When it gets to the keyword return, whatever's in here gets copied out So it gets copied out, and then if I save the result of the function, so I have an x, assignment here. I'm assigning the result of this function into x. That's this return. So that is the return value to be saved if whoever ran the function saved, let's see, did an assignment. Okay. So that's a prime function. We have, let's see, another keyword, return, and function, what those do. So you want to write down what those do. Let's see. Function is for defining a new function. And return is for returning a value as the result of the function. Okay, so is there anything we want to do? Let's say that's it for this one. Okay, so that is primes, and we did some new stuff. Happy primesing.